Okay, Algebra 1 students, in this video today, we're going to be looking at word problems from Chapter 3. So your heading for today is Chapter 3 Word Problems, Part 1. And be sure and include today's date in your notes so that your notes are organized. To be honest with you students, you will find some of these word problems in Chapter 3 easy, but others will be quite difficult, which is actually good for you guys. Challenging is good for you. Part 2's word problems, by the way, there are 2 parts, okay? Today's Part 1, tomorrow's Part 2. Part 2's word problems that we'll look at later will be more difficult than the ones we are looking at today for the most part. Being challenged is important, so please be ready for this challenge and work hard. As always, take great notes, pay close attention, and if you need to back up the video, then back it up and watch it again to help you. Let's get started. In your notes, by the way, some of these pictures I took came out blurry. I apologize for that. So, it might be helpful to have your book open to see the word problem a little better. Okay? So students, as always in your notes, excuse me, I would not personally copy this problem down. It takes too much time. I would just write down page 140, example number 4. Here we go. A single picture on a roll of movie film is called a frame. Motion picture studios try to save some older films from decaying by cleaning and restoring the film frame by frame. This process is very expensive and very time consuming. Okay? Now, the usual rate for taking and projecting professional movies is 24 frames per second. So, when you're watching an old projector movie in 1 second, 24 frames have flashed in front of your eyes. Okay? Find the total number of frames in a movie that is 90 minutes long. So students, let's think about this for a second, okay? We have a ratio here, or rate, 1 second equals 24 frames. Now, the movie is 90 minutes long, so I think it'd be helpful if we converted that to seconds. So every minute has 60 seconds, so 90 times 60 would be 5,400. So, when they ask you the total number of frames in a 90-minute movie, that's the same thing as saying, what's the total number of frames in a 5,400 second movie. Okay? So, if 1 second equals 24 frames, then 5,400 seconds equals how many frames? Let's cross multiply. 1 times x is x. 24 times 5,400. Of course, on word problems, you're allowed to use a calculator. So if you type that into your calculator, you will get 129,600 frames. So, in a 90-minute movie, there's approximately this many frames. Okay? Now, on to question B. If a worker can restore 8 frames an hour, how many hours of work are needed to restore a 90-minute movie? Now, guys, think about this. A worker can restore, here's a rate, 8 frames in 1 hour. Okay? So, how many hours will it take to restore a 90-minute movie? Well, we already found out how many frames We're in a 90-minute movie. It's right here. So if 8 frames take an hour, then 129,000 frames will take X hours. Okay? Cross multiply 8 times X, 8X, 1 times 129,000. Now simply divide both sides by 8, and we will get 16,200. That's a lot of hours needed to just restore one movie. Okay? But that's the answer. Okay? So we're using rates, and then we're solving for X. Okay, moving on to the next problem in your notes. Please copy down page 147, number 6, and let's take a look at this problem. The problem reads, a body temperature of 95 degrees or lower may indicate that the medical condition of the person is hypothermia. So, 95 degrees Fahrenheit might suggest hypothermia. Okay? So, what temperature in Celsius may indicate hypothermia? So really, students, all that you're doing is you're simply converting 95 degrees Fahrenheit over to Celsius. So we're going to take a formula like this here. We're going to put in 95 for F, and then we're going to convert it to Celsius. It does say right here, the Fahrenheit and Celsius scales are related by this equation here. Okay? So here we go. For F, I'm going to put 95, and then I'm left with a simple linear equation to solve. Remember your steps. Step 1, simplify both sides. That's done. Step 2, eliminate fractions. Your denominator is 5. We're going to multiply everything by 5. 5 times 95, 475. 5 times 9/5. Your 5's cancel, leaving you with 9C. And then 5 times 32 is 160. Now simply bring the 160 over, make it negative, and we're left with 315 equals 9C. Alright? If we divide both sides by 9, we should get 35. So, if your body is at 95 degrees Celsius, Fahrenheit, then your body is also 35 degrees Celsius. So here, we're just practicing making a substitution and then solving the equation. Okay, moving on to same page, number 7. Okay, here we go. The temperature within the Earth's crust increases about 30 degrees Celsius for each kilometer that you go down. Okay, so that's a rate. Alright, for every 30 degrees Celsius, we go down 1 kilometer. Okay, now if the temperature at the Earth's surface, or in other words, at the top of the Earth's surface is 24 degrees Celsius, at what depth would you expect the temperature to be? 114 degrees. Now, please do not put 114 degrees X kilometers. Please don't do that. Let me explain why. This is not saying when you're at 1 kilometer, it's 30 degrees. It's saying every time you go down, you're going to see a change of 30 degrees. Okay? So, on the Earth's crust, it is 24 degrees. We went down to where it was on 114. So, how do we find the difference? Well, we obviously subtract. Okay? So the difference is 90 degrees. Okay? That's the difference. So we can pretty much do this in our head. Every 30 degrees is 1 kilometer, and I have a 90 degree change. So that means I went down 3 kilometers. Okay? Or you could go ahead and say, for every 30 degrees change, it's 1 kilometer. So every 90 degree change, it's x kilometers. Cross multiply. 1 times 90 is 90. 30 times x is 30x. Then divide both sides by 30, and you'll get 3. Okay? So, if there's been a change in temperature, 90 degrees, that means we went down 3 kilometers from the top of the Earth's crust down. Okay? Alright, moving on to page 156, number 5. 156, number 5. Okay, students, in your notes, I would write page 156, example 5. Here we go. A video store charges $8 to rent a video for 5 days. There's another video store. They only charge $3 to rent a video game for 5 days, but you have to pay a membership of $50 every year. Which rental plan is more economical? Now, one way to do this is trial and error. Like say, okay, in 1 year, if I were to rent 20 games at this store, that would cost me $160. But if I rented over the course of 1 year, if I rented 20 video games in this store, it'd be $60 plus my 50 one-time payment, so $110. And so you can do that and go back and forth, but there's actually a much faster algebraic way to do this that I would strongly suggest. And here's what you do. You say, okay, the cost of one store is $8 per video. The cost of the other store is $3 per video plus a one-time payment of $50. Okay? Then what you do, students, is you pick up these two equations here, these two right sides, and you actually set them equal so that you find the number of videos to rent that would break even, like where the two stores would cost you the same. Okay? Watch how easy this is. This is called, by the way, finding a point of equilibrium. Okay? Finding a point of equilibrium. Bring your 3v over, make it a negative 3v. You're left with 5v equals 50. Divide by 5, and the answer is 10. So, let's check that and see if it's right, okay? So, I rent 10 videos. So from the one store, it's going to be $80 because I'm paying $8 a video. From the other store, it's going to be $30 because I'm paying $3 a video, but I have to add in my $50 one-time payment. So look at that, 80. So I can answer this question so easily. If you rent less than 10 videos per year, go with the store that has $8 videos. Okay? However, if you rent more than 10 videos per year, then go with the $3 videos. Okay? That's it. I mean, really, it's pretty simple. That's it. So yes, in these types of problems, you could use trial and error. You could have said, okay, how much would it cost for 5 videos, 7, and kind of worked your way up. That's fine. But this other way here is a lot more exact, and I think it's a lot faster too. So you write your two equations that represent the two stores, and then set them equal and solve, and that's called finding the point of equilibrium. And that's what I would strongly recommend. Okay, one more problem. Page 168, example 5. Page 168, example 5. This is a pretty tough problem, okay? So here we go. You're shopping for earrings. The sales tax is 5%. You have a total of $18.37 to spend. Okay? What is your price limit for the earrings? Now right away you might say, well, that's obvious. My price limit is $18.37. I mean, that's all I have to spend. That's not what they mean. They're talking about when you walk up to the shelf, if you see a pair of earrings for $18, should you get them, or would the tax take you over $18.37? That's what they're asking you, okay? What price, what sticker price or tag price can you afford? Alright, so here we go. Now students, think about this for a second. Let's see if we can't write a model that will help us. When you go to purchase anything in a store, we'll just say it's earrings. You take the earrings and you multiply them times the tax. Okay? Then you add that back to the cost of the earrings, and that gives you your total cost. For example, if you buy something for $10 and the sales tax is 10%, you multiply this times 10 and you get $1, okay? And then you add that to the $10 and your total cost is $11. So you take your cost of the earrings times the tax plus the cost of the earrings, and that will give you your total cost. Price of the earrings times the tax plus the price of the earrings gives you your total cost. So here we go. The cost of my earrings, I don't know what that is, times my tax. Tax is 5%, so 0.05 plus the cost of my earrings equals, what's my total cost? $18.37. Now, let's simplify both sides. Obviously on the right side, I cannot simplify 1837. Over here, I have E times 0.05, which would be 0.05 E. Then bring down your positive E. Don't forget, there's a 1 right here. We have two E terms. They're like terms, so we can add them together. So now I get 1.05 0.05e equals, because 1 plus 0.05, 1.05 equals 1837. Alright? Divide both sides by 1.05, and you will get approximately rounded $17.50. So now you can look at all of the tags on the earrings and realize as long as you stay at this price here or lower, then you will not go over the amount of money you have to spend. Okay? Guys, I hope this helps. The best way to work on word problems and to learn them and to get better at them is to work on them. So, obviously I've given you some homework to work on these things. Please work hard. I hope this video has been a help. If you have any questions at all, please don't hesitate to call or email.